Hi, my name is Ava Martino, and I will be presenting on Lab 2 of Physics 2211, Motion of a Falling Object. In the introduction, I'll outline the purpose of the lab and introduce some key concepts used during the experiment. I'll analyze the ball's motion and create two computational models in GlowScript, one with drag and one without, using the data we collected. Finally, I will address the questions what if and what does it mean. The purpose of this lab is to observe the motion of an object that is thrown and moves like a projectile. We will compare this observed data to that predicted from a computational model with and without drag. A few assumptions in this experiment are that there is no air resistance acting on the paper ball, and no other forces are considered other than gravity and drag. For a quick preview of the results, the computational model with drag force more closely resembles the data observed compared to the model without drag. In this scenario, our system is the ball, while everything beyond the ball, such as the air and the earth, constitutes our surroundings. Some important key concepts we used include drag force, which is a resistive force that acts opposingly to the motion of an object. You can view the formula at the bottom. And Newton's second law, which states that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. And gravitational force, which is the mass times negative gravity times j hat, where g equals 9.8 meters per second squared. Additionally, we utilize the position update and velocity update formulas. Here's a video of our paper and tracker data. The initial position of the ball was 4.9 e to the negative 3 in the x direction and 4.923 in the negative y direction, and the initial velocity was 1.477 in the x direction and 2.88 in the y direction. For the first computational model without drag, I changed the ball's mass to be about 0.0033 and then put in the ball's initial conditions and time step. Because this is the model where only gravity is affecting the ball and there is no drag, I kept b as 0. Then I put in the velocity and position update formulas. For the second computational model with drag, I kept the initial positions in their places and I changed b to equal 0.005, so now the computational ball has both gravity and drag acting on it. So I added the drag force to the net force formula at the bottom. When comparing the graphs from the computational models and the experimental data, you can see how the model with drag more closely resembles the tracker data compared to the model without drag. What does it mean? Is there terminal velocity? Terminal velocity occurs when an object is in freefall and experiences zero net force. When you look at the computational model with drag force at the bottom, you can see that the velocity decreases over time, which means that gravitational force and drag force are acting on it, eventually leading to a net force of 0. Now, what if the object was initially thrown straight up? If the ball was thrown straight up, the time it takes to reach the ground would be the same as when it was thrown like a projectile. The horizontal and vertical components are independent of each other, so the amount of time over the course of the movement would be the same. Thank you.